Q5197. A rectangular wing, as compared to other wing planforms, has a tendency to stall first at the A. Wingtip, with the stall progression toward the wing root. B. Wing root, with the stall progression toward the wingtip. C. Center trailing edge, with the stall progression outward toward the wing root and tip. The correct answer is B. In a rectangular wing planform, the airflow over the wing tends to be more disrupted near the wing root during a stall. This is because the wing root has a higher angle of attack compared to the wingtip, causing it to reach its critical angle of attack and stall first. The stall then progresses outward toward the wingtip as the disrupted airflow spreads along the wing. 5238. A propeller rotating clockwise as seen from the rear creates a spiraling slipstream. The spiraling slipstream, along with torque effect, tends to rotate the airplane to the A. Right around the vertical axis, and to the left around the longitudinal axis. B. Left around the vertical axis, and to the right around the longitudinal axis. C. Left around the vertical axis, and to the left around the longitudinal axis. The correct answer is B. This is due to a combination of factors. The spiraling slipstream, which is caused by the rotation of the propeller, creates a rotational airflow around the vertical axis of the airplane. This airflow creates a left-turning tendency, causing the airplane to rotate to the left around the vertical axis. Additionally, the torque effect, also known as engine torque, is another factor that contributes to the airplane's rotation. The torque effect is caused by the engine's reaction to the rotation of the propeller. In this case, with a propeller rotating clockwise, the torque effect produces a tendency for the airplane to rotate to the right around the longitudinal axis. 5209. An airplane leaving ground effect will A. Experience a reduction in ground friction and requires a slight power reduction. B. Experience an increase in induced drag and require more thrust. C. Require a lower angle of attack to maintain the same lift coefficient. The correct answer is B. When an airplane is in ground effect, it benefits from reduced induced drag due to the proximity of the ground. This allows the airplane to maintain lift with less drag and requires less thrust to maintain a given airspeed. However, as the airplane leaves the ground effect and climbs to a higher altitude, it encounters an increase in induced drag. This increase in drag requires the airplane to generate more thrust in order to maintain its airspeed and altitude. 5224. To produce the same lift while in ground effect as when out of ground effect the airplane requires A. A lower angle of attack. B. The same angle of attack. C. A greater angle of attack. The correct answer is A. When an airplane is in ground effect, the presence of the ground creates a cushion of compressed air underneath the wings. This cushion reduces the effective angle of attack required to generate lift. Therefore, to produce the same lift while in ground effect as when out of ground effect, the airplane requires a lower angle of attack. 5216. If the same angle of attack is maintained in ground effect as when out of ground effect, lift will A. Increase and induced drag will decrease. B. Decrease and parasite drag will increase. C. Increase and induced drag will increase. The correct answer is A. When an aircraft is in ground effect, the proximity of the ground reduces the downwash and vortices generated by the wings, resulting in a reduction in induced drag. At the same time, the cushioning effect of the ground increases the effective air pressure under the wings, leading to an increase in lift. Therefore, if the same angle of attack is maintained in ground effect as when out of ground effect, lift will increase and induced drag will decrease.